Today I'm going to be talking about areas of regular polygons. This is day 1 of chapter 11, section 3. So what we're going to do is we're going to be looking at some of the regular polygon definitions. Okay, and first of all, a regular polygon means all sides and angles are equal. Okay, so all the sides and all the angles are equal, and that's going to help us solve some of these, okay? So let's look at some of these definitions. First of all, we have the center of the polygon. Let's call that A. So that's point A. Next, we have a radius of the polygon. A radius is a line segment where we start at the center and we go to any vertex. That is a radius. Since we have 6 sides, we have 6 vertices, and also means we have 6 radii. But this is just one of them drawn. So that is your radius. The next piece is the apothem. Now an apothem is different because we start in the center and go down to the middle of a side. We have 6 apothems as well. So we have an apothem. Now the difference between a radius and apothem is that the radius goes to a vertex, the apothem goes to the middle of a side. Our last piece is a central angle. Okay, a central angle. And a central angle is formed by connecting 2 radii. So let's draw a radius, vertex to center. So this angle right here formed is your central angle. And there are 6 central angles within this polygon. Okay, so we have a radius, an apothem, and a central angle. And we're going to be using these to solve for different pieces. So let's practice finding these. The center of the polygon for this one is point D. The measure of the radius is 2.1. The measure of the apothem is 1.7. And the central angle is the 2 radii from here to here. So that's angle ADC. Okay. Now we can find the measurement of a central angle. Okay. If we were to draw a central angle on here, radius to radius, we can find that central angle by taking 360 divided by n, because if we add up all the central angles together, it makes a circle, which is 360 degrees. And if we divide by the number of sides, we get 1 central angle. Well, the number of sides for this one, so the number of sides for this is 6. So we can do 360 degrees divided by 6, and we get 60 degrees for our central angle. So we can find any central angle given the number of sides. So if we look at these next 2 problems, it says find the measure of a central angle of a regular polygon with a given number of sides. Well, if I give you 8 sides, we can do 360 divided by 8, and our central angle is 45 degrees. For 12 sides, we can do 360 divided by 12, and we get 30 degrees for that one. Next up, we can solve for different interior angles. Now, it doesn't look like I've given you very much except for some radii and an apothem and a 90-degree angle, okay? But I do give you the number of sides. So if you count the number of sides, 1, 2, 3, 4, 5, 6, 7, the number of sides is 7. We can use this one piece of information to find a lot of different pieces, okay? So we're going to hold off on finding the measure of ABC. The first thing we're going to do is find the measure of this central angle. This central angle right here, okay? So to find a central angle, we're going to do 360 divided by the number of sides, which gives us 51.4 degrees. So we know that that central angle is 51.4 degrees. Now we also know that we have an apothem right here, and it makes a 90-degree angle, but it also cuts that central angle into 2 equal angles. It cuts it into half. It's an angle bisector. So if we do 51.4 degrees divided by 2, we get 25.7 degrees. And so we know that this angle, both angles on either side, are 25.7 degrees. Okay? Now, let's actually look at our very last one. Find the measure of angle ABC. Well, ABC is right here. And if you notice, I've outlined a right triangle in red. To find ABC, we actually can add the 90 degrees and the 25.7 degrees, and we get 115.7. Well, since this is a triangle, we can use the triangle sum theorem and do 180 minus 115.7. We're going to subtract those two, and we get 64.3 degrees to get this missing angle. So we can find a lot of different angles within this polygon just by using the number of sides. So what we're going to do is we're going to practice using these methods. Okay, so the first one, we're going to find the measure of angle BED. Well, if we notice, since it's a radius to a radius, this is a central angle. And to find a central angle, we do 360 divided by the number of sides, which is 5 in this case, and we get 72 degrees. So if we can notice that's a central angle, we can find it very easily. Let's look at our next one. We're looking for ECB. We're looking for that angle. Well, since there's a 90-degree angle right next to it, we also know that this is 90 degrees. So that one was real quick and easy. All right, we're going to find our next one, DEC. Well, we know that that's half of the central angle, and the central angle is 72 degrees, so we divide by 2, and we get 36 degrees for that piece. Okay, our next one is CDE, which is here and here. And this one is where we use the triangle sum theorem. We can add 90 and 36, get 126, subtract from 180, and we get 54 degrees for that one. Okay. Our very last one is DEA. We go from D to E to A. Well, if we notice, DEA is two central angles added together. So we can add those two together and we get 144 degrees. So we can, just by using the side length, we found all of these different angles within this regular polygon. All right, our last piece is I'm just going to introduce you to finding the area of a regular polygon. All right, so to find the area of a regular polygon, we are going to use this formula, A equals 1/2 ANS. Let's talk about what each of these letters or variables represent. The large A stands for area. Our little a stands for apothem. The N stands for number of sides. The S stands for side length. So we need to find these three pieces to find the area of a regular polygon. So whenever I do one of these problems, I write down A, N, S. I want to fill in these three pieces to see if I have all of the pieces that I need for this area. So if we look at this regular polygon, do we have the apothem? Yes. That's 2 square roots of 3. Number of sides, let's count them, 5. And our side length is 8. So we now can plug this in to our formula, put it into our calculator, and we get about 69.3 units squared for the area.